Hello students, welcome to this lecture, and in this lecture we are going to study about shifted parabola, and then Pawan sir will tell you what is the solution of this question and you can check with your answer. So we have a parabola. If we take most standard form of parabola, let us suppose y square is equal to 4ax, which is having a vertex here, origin. If we take this vertex somewhere else, anywhere, suppose I take this vertex here, in general this point is alpha, beta, and we are drawing a parabola, just translating it here, and the same parabola I am drawing here. So what is the equation of this blue parabola? If this equation of black parabola is y square is equal to 4x. So what we have to simply do is, I am not going into translation of axis theory right now. Very simple application here is that the equation which is here will be now written as y minus, here y coordinate is beta of the new vertex. So y minus beta whole square is equal to 4a, and the x coordinate of new vertex is alpha. So x minus alpha. This is the equation of this shifted parabola. In any parabola, all the four forms of parabola which you have studied in the previous video, if you will shift the parabola such that the axis remain parallel to the given original parabola axis, here the axis is x, here the axis is again parallel to x, and the vertex moves to some another point, then we simply, instead of writing like this, we change it like this. If suppose it is x square is equal to minus 4ay, it will after getting shifted become x minus alpha whole square is equal to minus 4a y minus beta, because here the vertex was 0, 0. Here the vertex is alpha beta. So this is the concept of shift. Now sir, please explain our students that how can we solve this question by the help of this concept.
So students, here what is given to us is the coordinate of the focus, that is given as 2, 0. Equation of directrix is x is equal to minus 4. So just let us say draw these 2 points here. Now the focus is 2, 0, is 2, 0. X is equal to minus 4. This is the equation. This is the line representing x is equal to minus 4. Now, what is the coordinate of the vertex of this parabola here? So, the coordinate is midpoint of these 2 points here. So, this point has a coordinate of minus 4, 0. This has a coordinate 2, 0. So, the midpoint will lie at this point, which has a coordinate of minus 4 plus 2 upon 2, that is minus 1, 0. So, now, similar to what we have learned just, we can say that the parabola will be shift towards negative x-axis, and this point will be the vertex of that parabola. Now since we know the coordinate of vertex, what we have to do is we will put minus 1 in place of alpha and 0 in the place of beta. So what will be the equation here? The equation will be, it is y minus 0 whole square is equal to 4a, and what is the value of a here? So the value of a here is average of this distance, or the half of this distance, which is equal to 6 here. This is 6. So we can say that the a value, which is equal to 3 here, so we can write 4 into a is 3, and the coordinate of x will be x plus 1, because x minus alpha and alpha here is minus 1. So this is the equation, that is y square is equal to 12x plus 12 is the equation of this shifted parabola. So what we have to do is to calculate the coordinate of vertex, and then we can simply put the value of coordinate into the standard equation that we have just learned here.
So this is again a case of a shifted parabola. These type of cases you will see specifically in physics, in projectile motion. Further, there is a property of a parabola which is very important property, and that you will see in case of mirrors and lens in physics, which says that if we have a parabolic figure. There is a parabola here, which is, let us take normal standard parabola. This is applicable everywhere in any type of parabola. The property says that if we draw a tangent at a point and we draw a normal at the same point, which is actually perpendicular to the tangent. So, if a line is drawn parallel to the axis of the parabola here, and a line is drawn which is joining this point to the focus of the parabola, then this angle and this angle will be equal. Also, then if we proceed it backward, this line and this line, then this angle will also be equal to this angle. What does it say? In short, that the line which is parallel to the axis of parabola and the line which is joining the point with the focus will have angle bisectors as tangents and normal to the parabola at that point. This is a tangent at the parabola. This is a normal at the parabola. This is a line which is parallel to the axis of the parabola. This is the axis of the parabola. And this is a line which is joining the point with the focus. So if we take this angle, this normal is the angle bisector of this angle. And if we take this angle, exterior angle, then the tangent is the angle bisector of this angle. So in physics we may see this result that if a ray of light is incident on a point on a parabola, then it after reflection it passes through the focus, because this is the normal and angle of incidence is equal to angle of reflection in case of lights, we know in optics. So this you will also see in physics, which is a very important application. Here we come across this result that these are the angle bisectors. So the line which is coming here will go after reflection like this. Or if a light source is placed here and the light is coming like this, and after striking it will become parallel to the axis of parabola. So this is all, I think, students.
And these two have very important application at some point in physics. Like in optics, you know that we use headlight in cars. And what is the property of headlight? The property of headlight is we can see at a larger distance through the headlight. And how we can do that? So to arrange the system in such a manner that it will give our view at a very larger distance, what we do is the bulb of the headlight is placed at the focus, and the mirror that is in the headlight is, let us say, concave mirror. Then for that concave mirror is of parabolic shape, and the bulb is placed at the source. And as Subhu mentioned here, if a light will start from this point, that is focus, after reflection it becomes parallel, and you know that parallel line meet at infinitely large distance. So here what is the importance is, when a light starts from this, we can see to a very large distance, and this is how a headlight works.
So vehicles have two, low beam and high beam. So this is the case when it is in high beam. And if it is on a low beam, then it may not be parallel. So these are the...
And the other important application is we generally come across this antenna. Yeah. So what is the role of this antenna? So the role of this antenna is when the information or the signal is coming from a very large distance, we need a very strong signal to view our television. So what this antenna do is, this antenna is made up of a shape of parabola, and when the distance, since the satellite is at a very large distance, so the light is coming almost parallel to the axis, and since we can see that the parallel light will converge at the focus, so what this does is the signal that is coming over the parabola will converge at a point, and hence what we get is a very strong signal, and what is required to view our television in a clear picture in the television. So this is how the property of parabola help in various parts of physics. Some other applications are also there mathematically that we will discuss later on.
So we keep using that. We have to fix the focus. We have to. This is a very
That
important.
is why
part.
we tuned it.
Tune it. So
So this is how we tune the this antenna to get a clear picture.
So this is all for this lecture, students. In the next lecture, we are coming with the application of parabola in physics. Stay tuned and keep learning, students. Thank you.